we come to something that we've been waiting for a long time. We always expected a photoelectric question. In an experiment to demonstrate the photoelectric effect, light of different wavelengths was shone on a metal surface of a photoelectric cell. The maximum kinetic energy of the emitted electrons was determined for the various wavelengths and recorded below. So here we go. Now we're getting the inverse of the wavelength, and you know why we're doing that, because you remember this equation, H is C over lambda. So the inverse of the wavelength times 10 to the 6 meters to the minus 1. Okay, these values here. You could have just written down the wavelength. This one is obviously going somewhere with this, so just accept it for the time being. And then in our method of working out the maximum kinetic energy, you know, when the electron is emitted, we can work out its kinetic energy. And you see this is in very tiny units, 10 to the minus 19, but that's obviously got something to do with the fact that this is charged, the electrons are charged, and and of course the electron is a very, very small mass, not to do with the charge. It's to do with the half mv squared. It's the very small mass. So if we can work out V, we can work out Ek, because we know the mass of the electron, and there are the values. What is meant by the photoelectric effect? Okay, it is a process where electrons are ejected from a surface, and we'd better say metals, because I don't know if there are any non-metals. I suppose semiconductors possibly, from a metal surface when light, and maybe we need to say here, of a suitable frequency is a fancy word here, incident on it. So in other words, when we shine light onto a suitable, onto a metal surface with light of a suitable frequency, then electrons can be ejected.